Hello, this is presentation of our paper accepted at CVPR 2026 titled Grid Distillation, Compositional Image Distillation via Structured Generative Grids. Modern computer vision is fueled by datasets with millions of images, but this scale brings massive storage, compute, and energy costs. Dataset distillation tackles this by synthesizing a much smaller set of training images that still trains models nearly as well as the full dataset. We want to compress a class of approximately 1300 images down to as few as 10 images. Existing approaches fall into two camps. Batch-based methods like ardent stitch random crops together that is efficient but discards global layout and intra-class diversity. Diffusion-based methods like VLCP generate each image with a powerful prior, but each sample is created in isolation with no instance context. Neither approach captures both compositional structure and word knowledge at the same time. Our key insight is simple. Instead of generating images one at a time, we compress an entire class into a set of 4x4 grid of carefully chosen exemplars. Each grid patterned image carries three things at once: intra-class diversity through 16 distinct images, compositional structure through their spatial arrangement, and word knowledge through how we select them using clip embedding. Here we present the full pipeline. First, we extract clip embeddings for all images in a class, build an affinity kernel, then run our SSDIM optimizer to select 16 maximally informative exemplars. These form a 1024 x 1024 grid, which we downsample to a 256 x 256 distilled image. At training time, a one-step diffusion model restores fine detail, and grid-aware cropping preserves the compositional layout. Now in next slides, let us go through each step of the process. Stage 1 is the heart of our method. We formulate grid selection as a submodular optimization problem with three weighted terms. Alpha rewards coverage. Every image in the class should be represented by at least one selected exemplar. Beta rewards diversity. The chosen embeddings should span a large volume in feature space, using a determinantal point process style log determinant term, and gamma biases selection toward images that lie on the dominant manifold modes, those with the highest spectral energy in the kernel decomposition. We optimize with a Frank-Wolf continuous relaxation, round to a discrete subset, and refine with greedy swaps. The whole thing takes under a minute per class. Stage 2 fixes a key limitation. When we downsample a 1024 x 1024 grid to 256 x 256, we lose fine spatial detail. We adapt the InvSR diffusion inversion framework, a noise predictor combined with stable diffusion. Turbo restores the detail in a single diffusion step conditioned on a class-aware prompt. This adds only 16.9% one-time overhead, about 3 minutes versus 16 minutes of training. The last piece is grid-aware cropping. During training with probability 0.6, we use an aligned crop that starts at multiples of the grid cell size, preserving the compositional layout. With probability 0.4, we use a random crop for local variation, and critically, at inference time, we use standard 224 x 224 inputs. No pipeline modifications, fully drop-in compatible. Now let's look at results. On ImageWoof, a challenging fine-grained subset of ImageNet with 10 dog breeds, grid distill dominates across every IPC setting and every backbone. In the extreme low data regime, IPC equals 10, we hit 65.5% accuracy versus VLCP's 39.9%, a 25 percentage point gap. At IPC 50, we reach 84.3%, while VLCP plateaus at 58.9%. The pattern is consistent. The harder the regime, the larger our advantage. The same pattern holds across datasets and tasks. On ImageNet 1K, the full 1000 class benchmark, we reach 50.01% accuracy, beating VLCP's 46.7% by over 3 points. And the framework generalizes beyond image classification. On UCF 101 midframes, few short action recognition. Our grid LDC variant beats prior LDC by 7 points in the one-shot setting. The gains hold across all short regimes. Two ablations confirm what matters. Left sweeping the submodular weights on ImageWoof IPC20 shows that alpha dominant configurations wind coverage of the class manifold is the single most important criterion, right replacing our diffusion restoration with simple bilinear upsampling drops ImageNet. 1K accuracy from 50% down to 35%, a 15-point loss. Both stages are essential, but the win comes from combining them. To summarize, grid distillation introduces a compositional, knowledge-guided approach to dataset distillation. 3 contributions: SSDIM for spectral, submodular selection, one-step diffusion restoration, and grid-aware cropping, combined to deliver consistent SOTA across all benchmarks. Thank you. Find the paper on Open Review, and we'd love to chat at our poster session.